going to talk to you now about creation astronomy, observing the universe through biblical glasses. And you might ask, well, what does creation have to do with astronomy? I mean, a lot of people think that creation and evolution is about biology, and of course that's part of it. But really, it's about worldviews, isn't it? It's about who determines truth. You see, we all wear sort of mental glasses. We all have a way of thinking about things, a worldview, and that determines how we view the world in which we live. And I'm going to show you that when we view the universe through biblical glasses, it makes sense. It fits. And let's start with this wonderful statement that the Bible makes about the universe, that the heavens declare God's glory. And I want to show you that the incredible beauty and size of the universe demonstrates God's creative power. And let's just start with the size of things in the universe. And of course, the universe is so large, it's really difficult to comprehend in any sense how big it is, but I can maybe compare some things for you to give you a sense of it. And then we can compare things to larger things and so on and go all the way out. And let's just start with the sun. The sun is 93 million miles away. 93 million. Relatively nearby, of course, right? Can you comprehend how far a distance that is? 93 million miles. How long would it take to drive 93 million miles? Well, at about 60 miles an hour, it would take over 150 years to drive 93 million miles. I always thought driving through Kansas took forever, but that's quite a distance. You couldn't do it in your lifetime. But that's a drop in the bucket, because Earth is relatively near to the sun. Pluto is 40 times farther away. So it would take over 6,000 years to drive to Pluto. So if Adam and Eve, instead of eating from the forbidden fruit, had started driving on a very long road from Earth to Pluto, they would almost be there by now. And of course, that's just our solar system. And if we go out to the next nearest star, if I made the solar system the size of my hands like this, where would the next star be? Would it be at the end of the room? Well, it turns out it would be a quarter of a mile away. It's quite a distance. That's the nearest star. And of course, our galaxy consists of over 100 billion stars. And the Bible says God calls them all by their names. We don't even have that many words. Well, again, if I make the solar system this big, this is the orbit of Pluto, our galaxy would be larger than the United States. It's enormous. And of course, there are other galaxies, and they extend out further and further. It's amazing how big the universe is. And now I want to show you how incredibly beautiful the universe is, but I want you to keep in mind the incredible size of the things that I'm going to show you. And let's start relatively small with the moon. Now, the moon's not that big. It's only about the size of Australia, for example. It's not that big, okay? And the reason it looks fairly big is because it's pretty close. It's the closest astronomical object. Now, you can also see in this image, if you look very carefully, you can see Saturn. Saturn is this little speck over here beside the moon. And if you have really good vision, you might even be able to see its rings a little bit extending out to the side. You see, every now and then the moon will come and cover up a more distant astronomical object, and that's called a lunar occultation. Happens a few times a decade with something interesting like Saturn. And this happened a few years ago, and I got to see it. And I took this picture of it. And it was just lovely to watch Saturn, like this beautiful jewel, creeping out from behind the edge of the moon. Absolutely stunningly beautiful. And, astronomy is such a lesson in perspective, because you might think, well, Saturn is just this tiny little speck compared to the moon, but in fact Saturn is much larger than the moon, much larger than the Earth even, being about 9 Earths across. And Saturn has these lovely rings, which God must have really enjoyed making just for us to get a kick out of, I think. They're just beautiful, and they may look solid, but in fact they're made up of hundreds of billions of tiny little moons, and they orbit around the equatorial region of Saturn. Just incredible. But of course Saturn is relatively nearby. If we go out further into the universe, we go out to the realm of the stars. Stars are enormous, but they're tiny compared to the space between them. So if they look big, it's because they're overexposed on images like this. Now, we can learn a lot about the universe from stars. We can tell that stars are made of hydrogen gas, almost completely hydrogen, some helium. And we know that by the light they emit. You see, we can take that light and spread it out into the various colors And by seeing which colors are missing or which colors are present, we can determine what stars are made of. And this is, of course, good operational science. It's the kind of science we can do in a laboratory. We can take certain chemicals in a laboratory and heat them up and make them glow, and we can determine what they're made of by the specific color spectrum that they emit. And I've even done this with a pickle. It turns out that if you pass hundreds of, by the way, nobody try this. I don't want anybody to get electrocuted, but if you pass hundreds of volts through a pickle, it will glow a beautiful, eerily beautiful orange color. And that tells you that it's got sodium in it. It's a lot of fun. You can also tell the temperature of stars by their color, by the way. Hot stars are very blue, cool stars are redder, so. And just think of how much space this is occupying. It's enormous. Some stars come by themselves, others come in these enormous clusters like this globular cluster you see here. And these are, a few hundred of these orbit our galaxy, just outside our galaxy. And if you go out on a clear night and you take a set of binoculars, you will see little fuzzy spots in the sky, and a lot of those are globular clusters. If you point a small telescope at them, you will see 100,000 stars in a little sphere. Absolutely beautiful. But I have to admit, my favorite objects in the universe are nebulae. And a nebula is hydrogen gas that's spread out. So a star, hydrogen gas that's compact into a little sphere. And a nebula is just hydrogen gas that's spread out over an enormous amount of space. Some of these nebulae would take light years to travel from one side to the other. So you can just imagine how enormous they are. And they come in all kinds of shapes and sizes and beautiful colors, like the Eagle Nebula, which we see here. Some nebulae are called planetary nebulae, like this one. And that's where you have a star in the middle, and the star is injecting gas out the polar rotation axis of the north and south pole of the stars, where it's ejecting this gas out. It's a very, very gentle process as it leaks this gas away. And as you can see, it's just stunningly beautiful, I think. Now, I should mention that this particular work of art, as we're looking at this artwork of God, this particular work of art was not created directly by God, because the star is making that. But of course, God made the star, and He made it with the potential to produce this lovely nebula. There are lots of different kinds of planetary nebula. Some of them are circular, either because they're actually spherical or because we're looking right down the axis, because some of them are bipolar, like I said. Here's another bipolar planetary nebula. Just stunningly beautiful. One of my favorite planetary nebulas is the Ring Nebula. And it's not the prettiest maybe, but it is one of the easiest to find. You can see this in a small telescope if you know right where to look. And it's such a delight because it actually looks gray to the eye. You can't see the color as well. But if you take a small telescope and you just point it out at the night sky, you just see stars and stars and stars and stars. But there's one spot, if you point that telescope, you will see a little glowing smoke ring. It is so strange. And it just looks very different, very out of place than anything else you would see. Now here we have a very young nebula. This didn't exist 20 years ago. Okay, it's relatively new. And it's called a supernova remnant. So 30 years ago, if you'd have pointed your telescope at this spot, you would have seen a blue star. And that little star couldn't handle the pressure, and he decided to blow himself to bits. And sadly, he's no longer with us, but we have this lovely expanding star guts, as you can see here. And this is the first thing I've shown you that's not in our galaxy. Everything else we've looked at is just in our local galaxy. This is in a nearby galaxy. And there are, of course, many other galaxies, like the Whirlpool. This, again, is one of my favorites because it's one of the ones you can see with a small telescope, and you can see the spiral structure. A lot of galaxies do have this spiral structure, not all of them. And, of course, this galaxy would undoubtedly have its own set of star clusters and nebula and supernova remnants and the like. Lots of different kinds of galaxies of various shapes and sizes. There are galaxies in the process of collision. All kinds of galaxies. Galaxies of great beauty. Galaxies of great ugliness. Galaxies that look like flying saucers. Galaxies with giant black holes in the center. You can't see it. It's not because it's a black hole. It's invisible. But we have good indirect evidence that M87 houses a giant black hole at its heart. Galaxies come in clusters. This is an enormous cluster of galaxies. Everything you see here is galaxies. Each one made up of perhaps 100 billion stars. And you might even notice there are some very odd-looking galaxies that look like streaks. Can you see those? They look like they're all stretched out and distorted. And that's because what you're seeing here is an effect of general relativity. You see there's a background cluster directly behind the brighter cluster that you're seeing here. And the gravity bends the light of the distant galaxies and causes them to appear distorted. It acts like a strange sort of magnifying glass. Very, very odd. And so this is actually an evidence of, that relativity is correct, or at least a very good approximation of truth. But let's go out even further, close to the limit of what we can detect. This is the Hubble Deep Field. So this is peering out into space about as far as we can see. And you see just galaxies beyond imagination. Just incredible. And of course, this surprised some of my evolutionary colleagues that there would be galaxies this far out. They were expecting to see, they say you're looking back in time as you look further away, and they were expecting galaxies to be in the process of forming. And instead, of course, you see fully formed, fully designed, beautiful, beautiful galaxies. How awesome is our God? Amen? And